This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the arcsine and arccosine function in quadrant 1. We're going to begin with a 30, 60, 90 triangle. To remind you, the side opposite the 30 is x, the side opposite the 90 is 2x. The smallest side, largest side. The one in the middle, 60 degrees, is x times the square root of 3. Now we can use this to get sine and cosine for both 30 degrees and 60 degrees. So let's remind ourselves of the process. Sine of 30 is opposite over hypotenuse. Opposite is x, hypotenuse is 2x. So the sine of 30 is opposite over hypotenuse, x over 2x is 1/2. Now in radians, 30 degrees is pi over 6. So we know that the sine of pi over 6 is 1/2. If we're going to use the arcsine or inverse sine, we go backwards. X becomes y becomes x. So the arcsine of 1/2 will equal pi over 6. And the reason that's true is because the sine of pi over 6 equals 1/2. So if you know that direction, this direction is automatic for the first quadrant angles. Next we'll look at 60 degrees. Again, sine of 60 is opposite over hypotenuse. Opposite over hypotenuse, x root 3 over 2x will give us root 3 over 2. Now 60 degrees in radians is pi over 3. So the sine of pi over 3 is root 3 over 2. And then going backwards, the inverse sine or arcsine of root 3 over 2 would have to be pi over 3. So knowing the sine of 30 degrees and 60 degrees, we can get the inverse sine for those values as well. Let's take a look at cosine. So if I'm going to look at cosine of 30, cosine is adjacent over hypotenuse. Adjacent to the 30 is x root 3, the hypotenuse is 2x. So again, cosine of 30 degrees adjacent over hypotenuse, x root 3 over 2x, or root 3 over 2. In radians, 30 degrees is pi over 6. So the cosine of pi over 6 is root 3 over 2. Going backwards, then the inverse cosine or arccosine of root 3 over 2 would have to be pi over 6. That is our process. And we'll finish the 30, 60, 90s by looking at the cosine of 60. Again, cosine is adjacent over hypotenuse. For 60 degrees, adjacent x divided by 2x will give us 1/2. So the cosine of 60 is 1/2. 60 in radians is pi over 3. So we'll say the cosine of pi over 3 is 1/2. Therefore, the inverse cosine of 1/2, or the arccosine of 1/2, has to be pi over 3 in that direction. Okay, so that's our 30, 60, 90 triangles. There's one more triangle we want to use, namely the 45, 45, 90 triangle. This is an isosceles triangle. The sides opposite the 45s are the same. I'm calling them x, opposite each 45. The side opposite the 90 is x times the square root of 2. So I first want to ask about the sine of 45. So if we're going to use this 45, opposite over hypotenuse, x over x root 2, that becomes 1 over root 2, which is what I prefer, frankly. But if you rationalize the denominator, multiply the bottom by root 2 and the top by root 2, you get root 2 over 2. So be prepared for either version. In radians, 45 degrees is pi over 4. So we'll say the sine of pi over 4 is root 2 over 2, or the sine of pi over 4 is 1 over root 2. So if that's the case, again, x becomes y becomes x. The inverse sine of 1 over root 2 is pi over 4. Arcsine of 1 over root 2 is pi over 4. And let's look at the cosine of 45 degrees. Cosine of 45 degrees is adjacent over hypotenuse. Sine was opposite over hypotenuse. So that's incorrect. Let me fix that. So again, cos 45 is adjacent over hypotenuse, x over x root 2. It is again 1 over root 2, or root 2 over 2. 45 degrees is pi over 4. So the cosine of pi over 4 is root 2 over 2, which tells you then the inverse cosine of 1 over root 2 has to be pi over 4. So we've looked at sine and cosine for 45 degrees. We've looked at sine and cosine for 30 degrees. And we've looked at sine and cosine for 60 degrees. We want to be able to convert those to radians because our inverse trig functions are defined in terms of radians. Now we also have our unit circle. Our unit circle will help us determine inverse sine and inverse cosine for a couple other important values. So on our unit circle, we have theta is 0 here. The x value is cosine, the y value is sine. So cosine of 0 is 1, sine of 0 is 0. We have pi over 2 up here, cosine is the x value, cosine of pi over 2 is 0, sine of pi over 2 is 1. Those are the ones we really need, but as long as we've got the entire unit circle, let's just quickly mention that. Here theta is pi, cosine of pi is -1, sine of pi is 0. And down here at 3 pi over 2, cosine of 3 pi over 2 is 0, sine of 3 pi over 2 is -1, and then we're back to 2 pi. Cosine of 2 pi is 1, sine of 2 pi is 0. But in this lesson, we're focusing on the first quadrant, so let's look at these 2 points, 1, 0, and 0, 1, to determine the inverse trigonometry. So sine of 0 is 0. Here's 0 radians, or 0 degrees. Sine is the y value. Sine of 0 is 0. To do an inverse, x becomes y becomes x, so the inverse sine of 0 will have to be 0, indeed. Up here, this is now pi over 2. Sine are the y values. The sine of pi over 2 is 1. If that's the case, then the inverse sine of 1 would have to be pi over 2. And we'll do the same sort of thing with cosine. So at 0, cosine of 0 is 1. If cosine of 0 is 1, the inverse cosine of 1 has to be 0. And up here at pi over 2, that's the end of our first quadrant. The cosine of pi over 2 is 0. So if that's the case, the inverse cosine of 0 has to be pi over 2. So those are our notions. Now, if we put these things together, what happens? If I have the sine of the inverse sine of 1/2, how do I do the inverse sine of 1/2? What's the strategy I need? Well, I've got to think of an angle whose sine is 1/2. The sine of what value is 1/2? The sine of pi over 6 is 1/2. So we know that the arcsine of 1/2 is pi over 6. So replacing arcsine of 1/2 with pi over 6, now I have the sine of pi over 6, which is 1/2. And you might think that sine and arcsine just cancel, leaving the original argument of the function. And generally speaking, that's what happens. If I have f of f inverse of x, the result is x. We know that from algebra, but that doesn't always work that way in trigonometry. Let's take a look at another example. If I have the inverse sine of the sine of 3 pi over 4, so can you visualize 3/4 pi? Pi over 2 straight up and down, pi to the left, so 3/4 pi, 45 degrees in quadrant 2. But in quadrant 2, sine is positive. So 3 pi over 4 is in quadrant 2, and indeed sine is positive in quadrant 2 because the y values are going up. And then we have to ask ourselves, what's the reference angle? Well, if you're at 3 pi over 4, how much more do you need to get to pi, to get to the x-axis? The reference angle is always measured from the x-axis. If I'm at 3/4 pi, I need another pi over 4 to get to pi. Pi over 4 is my reference angle. So the sine of 3 pi over 4 is positive because it's in quadrant 2. And then we take the sine of the reference angle, so it's positive sine of pi over 4. So what is the sine of pi over 4? That's 1 over root 2. So this part in here becomes positive 1 over root 2. So I have the inverse sine of 1 over root 2. And then you ask yourself, what first quadrant angle has a sine that results in 1 over root 2? And the answer, of course, is pi over 4. So you'll notice the inverse sine of the sine of something did not result in the same something. And that violates our notions of how things should work in algebra. But the issue is the sine function is not 1-to-1. We're going to have to define that very, very carefully when we start going to negative numbers and quadrant 2 sorts of values. Let's take another case like this. I have the inverse cosine of the cosine of negative pi over 6. Can you visualize negative pi over 6? Negative 30 degrees. That's in quadrant 4. In quadrant 4, the x values are positive, so cosine is positive in quadrant 4. How about my reference angle? Well, if it's negative pi over 6, the distance or the angle from the x-axis to that radial line is going to be pi over 6. So pi over 6 will indeed be the reference angle. We know cosine is positive in quadrant 4. Reference angle is pi over 6. So the cos of negative pi over 6 will be positive because it's in quadrant 4. Then the cosine of pi over 6, since that's the reference angle. Positive, quadrant 4, cosine of pi over 6. But what is the cosine of pi over 6? That is root 3 over 2. So we get the inverse cosine of root 3 over 2. Now think of an angle in the first quadrant whose cosine is root 3 over 2. Well, the answer to that, of course, is pi over 6. So you'll notice the inverse cos of negative pi over 6 did not result in negative pi over 6, but instead resulted in positive pi over 6. So here's a quick summary of the facts of this lesson. The inverse sine of 0 is 0 because the sine of 0 is 0. The inverse sine of 1/2 is pi over 6 because the sine of pi over 6 is a half. The inverse sine of 1 over root 2, or if you'd like, root 2 over 2, is pi over 4 because the sine of pi over 4 is that value. The inverse sine of root 3 over 2 is pi over 3 because the sine of pi over 3 equals root 3 over 2. And the inverse sine of 1 is pi over 2 because the sine of pi over 2 is 1. Think the unit circle. Straight up and down, the y value is 1. And similarly for cosine, inverse cosine of 1 is 0 because cosine of 0 is 1. Inverse cosine of root 3 over 2 is pi over 6 because cosine of pi over 6 is root 3 over 2. That's 30 degrees, of course. The inverse cosine of 1 over root 2 is pi over 4 because the cos of pi over 4 is 1 over root 2. Inverse cos of 1/2 is pi over 3 because the cos of pi over 3 is a half. And the inverse cosine of 0 is pi over 2 because the cos of pi over 2 equals 0. And that will conclude this lesson.